Our last presenter is Martin de Villiers, and Martin was a presenter before on DecisionCAMP, and he shared his extensive experience delivering different projects across multiple industry, logistics, retail, healthcare, insurance, and what is important is that he has practical experience using operational decision-making systems. And today he will talk about a warehouse management system, modern warehouse management system. And I was once involved in this, but it was quite a few years ago when I saw preliminary slides produced by Martin. It's really impressive. So I'm looking forward to your presentation, Martin.
Nice one. Thank you very much. So I think I'll get right into it. I'm Martin de Villiers, originally from South Africa. My background, software development and architecture. I spent a good few years at MedScheme, where I met Dr. Alan Fish, who we just had a quick conversation with previously. And we worked on a nice project there with FICO technology and quite shaped my thinking about operational decision-making at that time. And because of that success, I was privileged to come and share some of that experience at DecisionCAMP 2018, which was in Luxembourg. So quite a lot of fun as I can recall it. And then I moved to the UK in 2019 and then started into technology in logistics. I managed to get into a job here and a completely new different world for me, but quite interesting. So today's talk is in that world. And one thing to maybe mention, because I have to mention the word AI 3 times. So I also work on a few AI projects at the moment where we're operationalizing and unlocking real business value from AI for businesses in sort of real terms. So it might be a quite interesting topic for the next time. Today's talk, not going to dive too deep into technical weeds. Instead, I want to share a story about the big impact of automating one specific key decision in a warehouse. And the story I'm trying to tell is to sort of give you the magnitude of the change that brought about. It reduced human error while still keeping people in the loop, which is quite another angle onto the whole thing. Although a lot of things getting automated quite a lot, we didn't quite get the humans out of the loop, or the intention wasn't to get them out of the loop. The difference is that their role was shifting and that they were now guided by systems and operating at a different level and making fewer manual judgment calls. So the backdrop of all this is a fulfillment warehouse. When I only practiced this presentation once and I listened to myself back and I said the word fulfillment, it doesn't sound like I'm pronouncing it right, but that is fulfillment. So if you hear me saying it, that's what I'm on about. So in this warehouse, they moved from manual pick faces to an AutoStore installation. And the AutoStore was embedded and transformed the way that the whole warehouse was working. Obviously, you'll see a little bit more about that later on, how that works. And then it kind of reached the ceiling and we had to dig to find a bit of a step change in performance. So we then ended up focusing on just one decision point in the inbound process. And we changed this decision from being made by the people to completely automating it. And then, like I said, the whole story here is about how this simple change amplified the value of what the business got out of that AutoStore implementation. So just before we go on, I'm open to taking questions if they arise. I'm not quite able to watch the Teams screen completely. I'll try and see if I can put the chat up. So if you raise your hand, I should see that. If I do miss you, if somebody has a question, I'm happy to interrupt. If you don't get my attention, just pop it afterwards. There will definitely be time for a bit of question and answers. And now for my second mention of AI. So I have to give credit to AI for these slides because I have zero design or artistic knowledge. And I just supplied coffee and some good prompts. And we came up with some slides that at least looks like something. So there we go. Second mention of AI for this presentation. Okay, so I'll set the stage and provide some background and context around the fulfillment warehouse, then examine a bit of the specific decision at hand and dive deeper into the physical process, because I think that story is quite an interesting world to see all the moving parts that's in there, and then how that decision then in the end influence the outcomes. I'll touch a bit on the importance of data, as we're talking AI, machine learning, rules engines, bespoke systems. Having timely, accurate, and clean data is critical to success. That's always the thing we fall back onto. And then lastly, I'll share some insights about the results we've achieved. Just a note that the content I'm sharing is intentionally high-ish level and does not include any sensitive detail from past projects or employers. Right, so if we start with the context a little bit. So in the e-commerce world, right after somebody clicks on checkout on their basket and completes their payment, that's where logistics obviously kicks in the background. So typically a warehouse is allocated, and then they get notified about the contents of this order and where to send it. So that's where it enters into our world that we're going to be talking about. The modern customer expects speed and reliability. So to meet these expectations, we've got to get the most out of our facilities. In e-commerce, the customer often expects, or we actually often promote, like next day or sometimes even same day delivery. This is like the one Amazon is very famous for. So powering all of that, we have these fulfillment warehouses. It contains a variety of products from a variety of sellers and partners, and sometimes a right mess actually. But right after that e-commerce sale is confirmed, the clock then starts ticking on these facilities to be able to fulfill that next day or same day delivery. And every second counts. Although I'm not always sure that the perfume that you order or the cricket bat has got that sort of urgency towards life and death, but somehow we live in this world where getting it to your door is fundamentally a big deal. Just want to make sure, Jacob, is the recording still running?
Yes, I'm recording.
Okay, sorry, I'm just seeing on the side here, there's something that looks like it's standing still. All right, perfect. So yeah, then we entering into this, orders landing into this warehouse, and the clock starts ticking for them to get the stuff out as soon as possible. So the efficiency of these processes then determine whether we can deliver on the end promise to the customer. And you can probably guess that's where automation plays a big role. So let's have a bit of a look at the automation in question. In a manual setup, storage is laid out in pick faces, so long aisles with racks where products are placed on shelves. When an order comes in, somebody picks a trolley up with a few containers and they start walking up and down the aisles, locating each product one by one. It's familiar like a shopping supermarket kind of experience. It relies heavily on walking and searching. In an automated or goods-to-person pick phase, the walking disappears entirely, and instead of people searching through aisles and looking for products, the system does the moving and delivers the right goods straight back to the picker's workstation. So this is your goods-to-person or goods-to-man setup. The specific automation system that we'll be referencing in this is AutoStore, which on its own has kind of shifted the industry. But just important to note that it's not the brand really that matters or the specific automation, but the principles apply to any automated storage or retrieval system. So optimize the product storage to maximize space utilization while ensuring that we have throughput and minimizing wasted time. So yes, I'm going to play a short clip. It's actually the first minute or so from a clip from the AutoStore official website. It does give a good idea of what it means and sort of gives in a minute kind of sums up what the manual pick phase versus the automated one is. So I'm going to test the technology to its limits here. Hopefully this will work for you.
We have stored things in shelves forever. It's natural to us. We want things to be within an arm's reach. Robots, on the other hand, shouldn't have to. They shouldn't need rows of shelves or long walkways. So why waste time on shelf-based solutions when AutoStore is here? AutoStore is a cube-based system, making use of all space for proper warehousing. Turn that wasteful air into storage and double, triple, or even quadruple the inventory capacity without moving to a new building. Bins are stacked right next to each other, on top of each other. Radio-controlled robots drive on tracks above the cube, lifts down to grab bins and deliver them to workstations for order fulfillment or replenishment. All operations get done efficiently and accurately in high-speed workstations.
Right, my timing was very good. I don't know why there's a thingy hovering there. Right, so at the end, I'll share a few of the links and stuff as well. You can, for those interested a little bit more in depth on that technology, there's a lot of content on there, and it's quite impressive how that kind of transforms these type of warehouse environments. So automated systems with robots always exciting, aren't they? So mental note to make from that video, note the bins that the robots were moving about, as they will be the main character of the rest of this story. As we today focusing a bit less on the robots themselves and more on how we make smart decisions before the robots even handle the products. So the question is how to organize goods efficiently in the AutoStore and get the most out of that system. So I'm going to talk a little bit about the warehouse processes. One key point to understand is the relationship between inbound and outbound processes. And this pick phase, in our case, this AutoStore sits right in the middle of that. So inbound covers everything that happens from the moment the delivery of goods arrive at the warehouse until they're placed in the right pick phase locations ready for retrieval for outbound. In practice, inbound often means breaking down the pallets into individual units, placing them in an organized way where they can be then easily accessed later. Inbound consists of all the handling and processes then until right before the products are placed into the pick phase or into the AutoStore in our specific case. Outbound operations side that deals with getting correct items out for an order into the parcel and into the hands of couriers. So that's kind of your inbound versus outbound. We're focusing quite a lot today on the inbound side because proper inbound handling, accurate put away into these pick phases, and some strategic storage decisions have a ripple effect on how the outbound performs. So if we get inbound right, your outbound becomes smoother and faster. If inbound is inefficient, then it creates bottlenecks that slow the entire process down. So final piece of the puzzle for the fulfillment context, in sort of day-to-day steady state operations, your order levels and volume are generally predictable and manageable. In this environment, as you saw in the picture there, somebody or in the video, we can pick and pack almost sort of in one flow, products moving directly from the storage almost into packing in one go. However, during peak periods, then that situation changes. Think about Black Friday, for instance. So volume spikes, the product mix is harder to predict, and the pressure to meet the delivery commitments is just multiplied. So in these conditions, sort of a proven approach is to do batch picking, where products are picked in bulk and then packed separately. So you can imagine then the difference in what we tell the system on bringing us products versus one at a time. We might be picking 10, 20, 30 of the same product because we're doing some batches. So we are expecting this black box that is this automation to be able to cater for both those scenarios and sometimes be able to switch between them with pretty short notice. So scaling is quite influential in all of this that's going on when we start looking and unpacking how do we actually populate this storage. I'm pointing this out sort of to highlight that those decisions during inbounding of goods must also consider this type of thing later on in the process. So our logic also has to consider what type of operations is on the horizon for this product. So in the near or sometimes not so near future, what is going to happen. So now that we've kind of established some form of context, let's have a bit of a closer look at our specific case and what it is that we are deciding during this inbounding of goods. So as you saw in the video, goods in the AutoStore are stored in these bins, some with compartments and others not. So when discussing these storage inside these automations, there are two sort of linked decisions for each product. The first is the bin type. So bins can be used whole or divided into halves, quarters, eighths. And each of these resulting compartments is then treated as a unique numbered location inside that automation. And it's also tracked individually by the system, both the automation as well as the warehouse management system. So these different bin configurations give us then flexibility, which is quite powerful, but also makes the inbound storage decision more critical. This is a key of the puzzle, as it's the link between the automation and the rest of the warehouse. So in order for this warehouse management system to know exactly which is in which location, it's quite important to accurately record that. So the second decision then that we make is how many units then to place into that bin at a given time. So we must optimize the storage while maintaining efficient throughput, but the product should be placed so that they can be retrieved quickly, sort of avoiding bottlenecks. So certain constraints limit how we can store products. So as you see later in the decision, we will talk a bit about what informs it, but the examples of constraints are avoid mixing different products in the bin. So if you can imagine in one of those bins, like the full one, if you come out with multiple products in there at picking time, you have to take your time now to pick the right product. So we don't mix products into a bin, quite a simple one. Avoid mixing different client stock. So again, in these fulfillment facilities, often they are acting as 3PL. So they've got multiple different clients that they do the fulfillment for, and they might sell the same products. So you don't want to end up mixing clients' products or have clients' products stored near to each other. So you also want to be able to prove to clients that you know where their products are and that you can easily get a handle on it and pull it out, etc. All very interesting things that makes life difficult if you think about one big sort of black box as automation system. Another constraint is avoid mixing batches or expiry dates. So again, when it comes to picking time, if inside the one bin we've got the same product with different batches, fulfillment requires often to, let's say, send out the oldest stock first. So if the products all look the same, you now have to inspect each one to find the right batch number or the right expiry date. And yeah, other examples of not mixing would be like clothing sizes, for instance. So if you mix different sizes of the same shirt, if you have clothing in your facility, it's hard to then dig in there and find the correct sizes on the order. So sort of using this automation is on the one hand very convenient, but splitting the products and making sure you store them in a fashion where when you need them out, you can quickly get the right product to the right terminal and actually make sure that the operator, without really having to think, can get the right product out. So I'll quickly talk through two scenarios of some of the impact of this decision of which bin type and how many items. Imagine we receive 3,000 units of a small product. So let's say a cosmetic sample product, which is often small tubes or small sachets. So operators can consolidate all of them into a single bin, so they can choose this one full bin, and just because they can fit in there. So the use of space seems very efficient. So we are utilizing only one bin, very dense, and the least amount of wasted space. Now say the client who we fulfilling that product for runs a promotion on their e-commerce platform and saying that for the next 3,000 orders in that sales channel, exactly one of those units are going to be given away as a gift with purchase. So every one of those orders now suddenly need to retrieve that same bin. So when those orders land in the warehouse, we have several ports at the AutoStore busy picking and packing orders, but we only have one bin containing this product. So immediately now we've created a big bottleneck. And for those 3,000 orders are going to come out very slowly because that bin is going to be bouncing to try and fulfill each one of those orders. So kind of here it seems like a smarter choice would be to split the items across multiple bins. So some multiple robots can retrieve them in parallel. So if we extend that scenario, let's do that. So let's say the same 3,000 small products come in, but this time we decide to spread it across, say, 30 bins. So what's that, 100 units per bin? And again, we chose this bin because just on that day that was convenient, and that's the one that came out, and we just put them in. So we use 30 of these bins. We put 100 units in each bin. So this greatly spreads the access. So each bin, now, we don't have it in one bin only, so that bottleneck is somewhat avoided. But now each bin is only about 3% full. So if this product now ends up selling slowly and is not promoted and gets out quickly and sits there for potentially weeks or months, we are tying up so many bins and valuable space for quite a long time. So as you can see with the sort of two extreme cases of how to handle that specific item, optimal storage lies obviously somewhere in the middle, or it seems like it does. So these decisions here must balance now the space, the efficiency, the throughput, and considering the demand and other constraints that we've got. So it's becoming clear that leaving this to people is quite insufficient, and intelligent and flexible decision logic here is needed to constantly make the right choices. So at that point in time in this story, we realize that we are going to reach a ceiling of what we can get out of this automation unless we start addressing this problem. And it's kind of a problem that's kind of glaringly obvious when you look back at it, but not that obvious at the time when you really starry-eyed and you install the AutoStore and you start seeing the robots move and all the throughput. And then you get down to the nitty-gritty of this is where sort of the importance of doing a bit of analysis and a bit of decision modeling was very handy. So I'll talk a little bit about the processes here. So it might be a little bit boring if you're not interested in warehouse and fulfillment, but we'll have a look at the process before and after, and then some of the DMN and where we've injected this decision into the process. So on here, we have two inbound warehouse processes, decant and put away. So first, if we just look at, for the sake of terminology, we've got this T-bin and A-bin concept that I've annotated with. So T-bin is transport bins, which are these plastic bins that you can see moving around the warehouse. So they can go on conveyors, they can be carried on trolleys, stacked on pallets. So I've denoted them as A-bins, as T-bins. And then the other one is the A-bins, which is the one you saw in the video, which is the automation bin. So they stay inside the AutoStore grid itself. They never come out, and they're the ones that can have those dividers to make them certain different configurations. Sort of understanding this distinction just helps to sort of frame this flow of goods as they move through these processes. So A-bins never leave the automation. T-bins are the ones we use outside of the automation. So a general thing also to point out before I go step by step quickly through the processes, if you note on these two processes, this is all to do with inbound, and end to end, it sort of brings us from the pallet all the way through to where this goes into the automation. There's two counts here, if you can see that, and there's also sort of manual decisions being made here. So the person here at some point decides what type of A-bin and which configuration, and they also decide quantity and count quantity twice in this process. So just sort of to point that out at the high level. So now on to the little bit of detail on the decant process. So the main goal on decant, if you take this process on top here, things take it from when the pallet arrives. We've decided this pallet is for fulfillment. It could go down another path, which means it's not for us. If it is for fulfillment and it needs to go into our automated storage, we need to break this pallet down. We need to record the products. We need to count them out, and we need to place the goods into the sort of auto store facility. So that's kind of obvious what we're doing here. Some of it is quite ugly. I mean, breaking a pallet down is breaking wrapping and boxes and kind of digging for product, and sometimes also even knowing when to stop digging. So some products is not for sale as an individual unit. You have to, for instance, keep the 6-pack together, etc. So that's all kind of manual, and people doing that manual process. We haven't yet got robots that can unpack pallets without breaking everything. Then at some point they start counting the product once they've got to the actual product that is the raw product that's for sale. They'll then fill a T-bin, and here this count is completely up to them. So they decide, I don't know, if it's a heavy product, they might not fill it completely because it might be difficult to move around, or they make some decisions on their experience on how many products to actually put in there. They record this quantity in the T-bin and they release this T-bin. So on the WMS now, you have this T-bin with this product in it, and the system knows how many goods is in that bin. Obviously, they'll continue doing this until they finish with their pallet. Then if you follow it from there, there's a transport that happens between this process and the put away process. That could be kind of instant, within a minute. It could also be like the next day. But the process then continues when that T-bin that we've created earlier arrives at the put away. So at the put away station, they would be scanning it. Here's another manual decision that they're making. They then choose this A-bin type. So those configurations we saw, they look at the product, they use their experience, maybe some notes that they've made in the past, and go, typically we use a half bin type or a quarter bin type or a full one. And they then sort of also choose how many they want to put in there. So then they record that quantity on the system. So then we end up with the A-bin with the product into it, and now it's in the automation. So from now on, if we need to get that product out, we can ask the automation for that product, and it knows which of these bins contain them. So quite a mouthful there, but end to end in the inbound process, we've got sort of a double count. We've got a manual choice here of an A-bin type. And if you look a little bit back on what we wanted to achieve, is we want to say, we want to make the decisions better on which bin types do we use and how many products to put into that bin type. Now, that decision, again, is sort of spread across a few points here, and it comes nicely together if we break it down a little bit further. So the systemizing this choice is sort of then the next thing. If I go then on to the after process. So on here, I've just taken the top process, which was our decant, and I've just shown what the changes were that we made there. The process itself is not a lot different in this case, but you can see we've injected the decision now in here. So the earlier we make this decision in the process, the better. So in our case, this happens as soon as we know which product we're dealing with. So this early decision then allows us to guide the flow of goods from that point onwards. The decision output is then used in two places. The first one is right here in this process, where the operator then decants the number of products that the system tells them. So that bin, that empty T-bin that they've got, they now get told how many items to put in there. And at the same time, the system records the future A-bin type that it wants to use. So the system kind of stores against this T-bin the concept of a 1.1 or a 1.2 or 1.8 or whatever size of the bin eventually it is that we're going to use. A note here about the counting. So to improve the quality of the count, we also employ techniques such as weighing the bins. So after the count, it also goes on a scale, and if it is within tolerance, it's green. If it's not, we sort of sideline it. So the reason why extending that a little bit is obviously we're going to end up with only this one count, as you'll see on the next slide. So this count now becomes quite important. It's the only time we are going to record how many of these items are going to end up in that specific location. If we get that wrong and we push it into the auto store, it's in the black box now, and that'll be the truth until somebody manually pulls that bin and inspects it or corrects it. So getting this right, so I said earlier, we didn't really change the process much. The happy path process wasn't changed, but the unhappy path has been sort of extended to say, let's weigh it as well and let's look for tolerances and make sure that we give the best chance for this count to be accurate, because it's the only time we're going to count it. So if I now move on to the put away side of it, so the new approach now at put away is all about using the data we've already captured. So thanks to this decision point that we had in the DCAMP process, the bin type now for the automation is predetermined. So this critical information now travels with the product on the transport bin, linking those two processes now. So even though they're distinct and asynchronous, it means that put away can happen minutes or even hours after decant, but it will have the selected A bin type now already done for you. So this, it's kind of, without even pointing too many things out, quite obvious that it's a lot slicker. There's no manual count here. There's no need to make decisions as a operator that's standing on the floor doing the work. So because the system already knows where the product needs to go, the put away process is then pretty much a matter of, if it fits into the A bin that comes out automatically, then you push the button and you're away to the races. So we've eliminated this need for the second count, and that was also a frequent source of error. So the process is quite streamlined and highly efficient in this case. Again, to ensure accuracy, we've got a few simple checks in place. So scanning the product again in that process, it just gives us that second sort of double check. So you scan this T-bin, the system knows what's there, what to expect. It asks you to scan one of the products in there just to make sure you didn't swap the T-bin for another bin or something happened in between the time it takes to get from decant all the way to put away. There's also exception flow. So if an operator here cannot physically do what they are told, so they are basically told, take everything from this T-bin and put it in a specific compartment. If that doesn't fit, there's ways for them to record that. And that's quite important for us because that's our feedback loop. So again, a little lie that I said we didn't change the process, but that process was sort of bolted on as an unhappy path process. So we have an instant feedback loop of when these things go wrong, because that means we've got somewhere in our decision, some input was wrong, or we've got some wrong information, or there's various things that go. And that learning was probably one of the most important things to add to this, because over time it went from a 80% accurate to like a 95% accurate, because the edge cases were always there. So you learn from those kind of things where dimensions were recorded wrong, or any of those upstream data sources that could have caused an issue. So we learn very quickly from them. And then obviously making sure that the warehouse operations doesn't stand still when something like that happens. So it's a quick way to record it, push the thing to the side and take the next one and continue with the job. The last part about the process then is, let's have a bit of a look at the DMN. This diagram illustrates the logic behind our automated decision. So there's quite a lot that goes into this. I'll touch on some of it. It's quite a powerful model. It brings together data from across the business to make this single intelligent decision. At the center of this decision is our determined bin type and fill quantity. So this node is where all the information converges to produce the final output. The key to its accuracy lies in the various inputs it considers. So firstly, it looks at the product itself. So to make this possible bins for this product decision, look at the product itself, calculate the subset of possible bins. So this is a crucial decision where we use our bin capacity calculations and available bin type sort of setup to filter out anything that physically wouldn't work. Then that decision goes beyond physical fit. Then the model also considers, in the ultimate decision then that it makes, it also considers the sales product, the current stock position, the current spread of the product. This data is also influenced by external factors like their sales and marketing, some demand signals. It's all analyzed by quite a sophisticated data science model to provide like the most current and relevant insights. And then finally, the decision is fine-tuned by sort of a set of rules. So we consider physical constraints of the warehouse, automation overrides. There is also product properties like fragile products or hazardous materials or combustibles that have different rules. So sometimes those need to kind of override what the optimal storage is and actually sort of bring it back down to what's governed by other factors. So bringing all these data points then together from a physical product attributes all the way through to real-time sales data, this decision engine then ensures that every product is put away with a purpose. So optimizing the storage capacity and our ability to then fulfill future orders. On a point of interest, in my final sort of mention of AI, there's quite good models out there that can ingest and understand images. So I use Google's Gemini 2.5. So I took a JPEG of this DMN and just gave the JPEG to it, and basically it came up with this narrative that I presented now. So it's quite an interesting one. So if anybody's using some of these things and you have to reverse engineer, AI is actually pretty good at reading the sort of structured things like DMN. Right, so getting sort of closer to the end, want to just talk a little bit about the importance of data. So in this case, it is a company running large e-commerce, their own e-commerce, in-house logistics, as well as providing logistics services like a 3PL, providing that to clients. So to say that the data landscape is messy, it's creatively messy. So different platforms with different technologies, different teams looking after each of them. Each of these have its own roadmaps and priorities and projects. So a lot of the graft here was knocking on many different doors, trying to get this information from all these disparate sources and to line it all up. So integrating what we can, reusing everything we could find. The data was sourced from many different upstream systems, from within the WMS, from within the automation itself. There's handy information about how many bins is currently being used for this product, all the way down to what was the basic rules of the automation. You have to have at least 2 bins for each product, etc. There's a multitude of these things. One of the other things which was quite key here is the nature of data science. So data science kind of moved here from typically being just in a corner and doing sort of big data and reporting and producing dashboards and static point in time things, to actually creating sort of pipelines where it all becomes it comes to life kind of thing. So the data science is sort of inline. Every time we make that decision, a certain part of it is relying on either instant or near instant sort of number crunching happening to inform what's the latest view on that specific aspect that we sourced from the data science team. Quite a good experience that was as well, to sort of bring that out and sort of turn the whole way that we see data science in that specific case. The other thing to mention is we baked in feedback loops. So that was something that with the manual decisions, you'd hardly ever get any feedback. So you look at it afterwards, you go, why did this land up in that spread or this? You might ask a person and get a really good answer, but you might ask somebody who's either not working there or they're not on a shift, or it's just because people, it's not their job to write down every decision they make. So because of the way that it's implemented here, we have these feedback loops, and every decision is now, its inputs and outcomes is all there, and we can mine that data and we can rank them and we can fine tune the stuff. So that's another kind of where we look at the data journey from end to end. So there's all the sources and systems. We have the data science just in time. We have the utilization, but then importantly is the data we create out of this to be able to then learn from it and sort of make the system self-heal, self-learn. A classic case which I always laugh at when we ask the data scientists about some of their algorithms on what can fit and what can't fit on things. And we said, so what is your basic way of finding things that won't fit? And the one guy said, it's really easy. So the first red flag is when the dimensions make it look like it's lighter than air or heavier than lead. That's kind of an obvious case that there's something wrong with the dimensions. So it was quite an interesting one. Right, so some of the outcomes. So keep in mind that the gain shown here was not as a result of AutoStore automation, but rather as a result of doing so much better with it by baking this real-time decision into the process. So I can't share exact figures, but the data sort of paints a clear picture of the transformation of our warehouse operations. So in a sort of what you can call it comparative way, this is quite real life. It's just not actual data. So as you can see on the bar chart, the single decision had quite a measurable impact on our operational metrics. The decant one, it didn't reduce drastically because that was the process at the top where we didn't really change the process that much. But even that got a bit more efficient because people were told exactly what to count. So they didn't have to try and work out how many to count. They were told how many to count. This shows that even that process kind of benefited from that. If you then look at the time on task for put away, which is in the middle of that graph, by making the right decision up front in DCAMP, we've now radically simplified that put away process. So it led to significant reduction in total time spent on that activity. Obviously also reduced errors by quite a lot. That's one of the most visible gains of that new process, or of the process beyond the implementation of that decision point. Equally importantly, if you look at the unused capacity of the AutoStore, this is where we see a direct financial impact. By optimizing those decisions on bin type and fill quantity, we've drastically reduced the wasted space. So this translates into greater storage density and also allows us to get more value out of our physical assets. So these measurable gains then directly led to the key outcomes that we've had, and we've achieved greater inbound efficiency, optimized space utilization, and seeing improved inventory accuracy. So all of that contributes to reduce wait time at peak, speeds up the entire fulfillment process, and make the whole facility just run at scale much easier. Yeah, and then also the last little bit is the continuous improvement gains that came out of there. I spoke about the feedback loops quite a bit, and that just kind of makes sure that it will sort of stay relevant as time moves on and things change, because the system sort of learns from itself. The kind of fundamental improvement to the end-to-end, sort of keeping that facility sort of on its toes, if you want. And then ultimately, of course, all the outcomes culminate in dollars, so significant cost savings across the board for the business at the end of the day. Right, and that kind of brings me to a pretty speedy end, I think. You're muted, Jacob.
Oh, I'm muted. Okay, Martin, thank you very much. It was a very specific presentation, and Denis has a question.
Yeah, I have quite a few questions actually. So I don't want to hold up everybody. So stop me. First question is when you were introducing the decision and the DCAMP process, it wasn't clear to me if that decision is made once for the full pallet, or as things progress, do you redo that decision to decide maybe a change of bin? You know, we start with full ones and then we decide to go to half ones, and
yeah, 100%. So it is made for every scan. So we try to make it for every container that's filled, because that does change the picture. So one of the things that was taking into account is how many bins already contain that product. So as we create these new bins, more and more of them that does contain it, it did change it. So you might find we create a few of the smaller ones to create a bit of spread. And then as the system learns there's a lot more of this product than either what we expected or what was actually delivered, then it will start saying, okay, now start putting it into the bigger bins, fill more of them at a time. So absolutely, it was sort of made with each product, yeah.
Okay. And my other question is the relationship between the predictive models and the decision model. So you have a decision model that makes a rule-based decision, from what I understand. What's not clear to me is whether the predictive model are used to specify the rules, or whether the predictive model play a direct role in influencing the rule.
So the predictive models was more around the demand signal and these promotions and things like that. So that sort of sat on the outside with sort of an API you can go into and say, I need to know what's on the horizon for this product, but for a few permutations. So what's going to happen in the next day, the next week, and the next month kind of thing. So we leaned on it when the decisions were run. Those would almost be like just data inputs into the decision.
Yeah.
And the predictive model would have worked that out. It constantly kind of updates itself. And again, there at one point we were doing it, download this almost like once a week kind of thing. But then we realized that changes so quickly. We needed to have it nearly real time. And that's where the whole shift happened with data science. We went to them and go, can we get this, let's say, instantly on real time? And they went, what? It takes us a day to produce this. And then we went on that journey and got it to a point where we could literally query at almost any point in time, which was quite interesting.
So again, last question, to qualify some of the words you use. So you were talking a lot about optimization, but there's no real optimization in the traditional sense of optimization that we know. The optimization is made by a rule decision that's deciding at the point of DCAMP what should be done. That's a very specific decision that is made. And it's the influence of the looping that provides you some balance of optimization.
Yes, that's true. Okay. Because at the point where you make that decision, you don't know how long it will last. So it's you make that decision now because we know what we've got, we know what we're going to get, and what we think we're going to sell. And that's the best we've got at that point in time. And as you get better at ultimately, really, to think it back to your point about the predictive models, is anything that really goes red mostly goes back there where we go, well, if we only knew this was going to be promoted, or if we only saw that sale coming, those are the ones where you go like, how did we get it this wrong? And that's like, but the luxury of having that plugged in at least sort of gave sort of the 80-20. So 80% of the time you're good, 20% of the time you get it really wrong. Like in my example with the 3,000 units in one bin, that kind of thing.
Thank you. Very interesting.
Okay, Alan? Oh, somebody else has questions? Okay, Martin, you mentioned that you're not using optimization engine, linear or constraint engine at all?
The data science guys might be doing some stuff like that, but not in this specific, not in the side of the storage decision that we're making.
Because if you listen recording of what Mainlove Selman presented, you will see a lot of similarities and very good recommendation to solve these problems. What you're talking about, when you don't have exact predictions, you actually your problem deals with uncertainty. And how to deal with uncertainty, this is a very, very special issue that it's several methods, and Mainlove presented some of them. So I would strongly recommend you to look at this, or maybe even contact him directly. He would be happy to assist.
I'll definitely listen to his one.
Okay. Any questions? Martin, thank you very much. It was a very good presentation, and all the best.
It's a pleasure.
Okay.